Hello everyone, welcome to Mathematics Method Unit 1. This video will talk about some part of 6i on your booklet, quartic and other polynomial function. And our learning intention can focus on the even and odd function. The success criteria, we have two. First one, I know how to identify if a function is an odd or even function. And we also will do the second success criteria, I know the properties of odd function and even function. Okay, as if you look at about the topic title of your 6i, quartic and other polynomial function. Okay, so quartic function and other polynomial function, other polynomials. Okay, so these two and its graph. Okay, and its graph. Now, this is the first part of your booklet for 6i, and then I will just leave it over there and for you to have a look and to study by yourself. And the example covered in your booklet that is related to this part called quartic function and its graph is example 33 and example 34. Okay, these two examples are also very important. Make sure you fully understand them by reading the textbook solution. Okay, this video we're gonna focus on the second part of your 6i, the even and odd function. Okay, now even function and odd function. So first of all, we're going to talk about the property and the definition. Okay, so even function. What is the even function? The property is even function f of x will be equal to f of negative x will be equal to f of x. Okay, so that's a property of even function. And graphically, the graph is symmetric about y-axis. Okay, so what does it mean? Okay, so now if you have a look up at my the left hand side of this display, and here is the graph for my even function. For even function, the graph is symmetrical about the y-axis. Okay, so now they are symmetrical against the y-axis. So now, you see, if I continue to draw an even graph, and you can see this graph is symmetrical about your y-axis. Okay, so now you see I come back. Let me redraw that again. So you see they are symmetrical. Okay, so this is the property of the even function, and then algebraically f of x need to be equal to f of negative x need to be equal to f of x. Okay, and we're going to talk about the algebraic property of even and odd function later on, but here I think this graph helps you truly understand what does it mean by symmetrical about y-axis for even function. Okay, so now this is the two properties. And odd function. Okay, so odd function, the property algebraically is f of x is equal to negative f of x. Okay, then the second part is the graph. The graph is the graph has rotational symmetry in regards to the origin. Okay, what does it mean? Okay, so now if I draw a graph, okay, so let me draw a graph. So if I have a linear graph like that, so this is my linear graph. The graph has rotational symmetry in regards to the origin. That means we rotate the graph 180 degrees in regards to in regards to 0, 0, which is the origin. Okay, so now you see here is my origin. I am going to rotate this graph in regards to origin for 180 degree. Okay, so I'm gonna rotate this for 180 degree. So then the graph will be this. Okay, so this is the property for odd function. The graph has rotational symmetry in regards to origin. All right, so let me draw another one. If I have, for example, if I have a curved graph like that, like a semicircle, all right, and then again we rotational symmetry in regards to origin, so we're gonna rotate this graph for 180 degree. So therefore, if I rotate for 90 degree, then the graph gonna be look like that. And so this is 90 degree. If I then continue to rotate, the graph gonna look like that. Okay, so this is 180 degree, and this part will be the other part after you rotate the graph for 180 degree. Okay, so now you see if I on my left hand side, if I take away of that graph, now if I pick odd, and then let me go back, so you will see it has a rotational. Okay, so basically we rotate the graph for 180 degree in regards to origin. Okay, so this is the property for odd function. Another property that works for both even function and odd function is that we have f of 0 equal to 0, because all of this graph, they will pass by the origin. All right. Now, here we have learned the property for even function and odd function. So algebraically, f of negative x equal to f of x, that's the case for even function. However, algebraically, when f of negative x equal to negative f of x, this is the case that telling you the function is odd function, okay? And then for even function, the graph is unsymmetrical about the y-axis, and for odd function, the graph has a rotational symmetry in regards to the origin, which means we rotate the graph 180 degree in regards to the origin. Okay, so now coming back to our example 35. Example 35, we are asking you to state whether they are even or odd function. Okay, so we know even function, algebraically, f of negative x equal to f of x. Okay, so now as long as we can prove our function match this property, then it's even. Or if it's odd, f of negative x equal to negative f of x. Okay, so this is basically what we're doing. So now let's do example A. F of x is equal to 6x to the power 4 minus 3x squared. Okay, so this is my function. So now let's have a look. I'm gonna try f of negative x. Okay, so now I am going to replace my x by negative x. Okay, so therefore my equation become 6. Okay, so that x become negative x to the power 4 and minus 3 times that x will replace by my negative x. That will become negative x to the power of 2. Okay, and then we know positive power, that will give me a positive. So that can that give me 6x to the power of 4 because it's even. So it can cancel out my negative. Minus 3, that's even power, so cancel out my negative sign over here, so that'll become straight x squared. Okay, and then you compare this part, it is actually equal to f of x. Okay, so basically, therefore f of negative x is equal to f of x. Therefore this is the property for even function, so therefore the function f of x is even. Okay, so this is how you prove whether a function is odd or even function algebraically. All right, now another one we can do is C. Okay, if we do C, I do B. g of x is equal to straight x to the power of 5 minus x to the power of 3 plus x. Okay, so now again we're gonna prove, so we're gonna use the property. So we're gonna try a g of negative x, okay, to see what we got, and then that will give me equal to straight times, okay, so I am going to replace this x by negative x, okay, so that will be negative x to the power of 5 minus is from the formula, and so that x is going to be replaced by my negative x, so will be negative x to the power of 3 plus x. So your next plus that x will be replaced by negative x as well. Okay, so now we can say straight, and then because this is odd power will keep that negative sign inside over here, so that will give me negative straight x to the power of 5 minus, okay, because again this is negative power, this is odd number power. Odd number power will make you keep that negative over here, so then you will have negative, so minus negative x to the power of 3, okay, and then plus, so plus minus, so you need to keep that minus x. So therefore, if we simplify, you will get negative 3x to the power of 5, then minus give me positive, which is plus 3 cube, and plus minus, so here will be simplified minus x. So compare this graph over here, you see that is not equal to g of x. However, now, so we're going to try g of x, because we know g of x is equal to 3x to the power of 5 minus 3x cubed plus x. So we can try negative gx. Okay, so negative gx, it is actually equal to negative, so negative, that whole lot is my g of x, okay. Now I expand the bracket, so that will be negative 3x to the power of 5 minus positive x to the power of 3 minus plus giving minus x, okay. So you see here, this is equal to this, so that tells me therefore g of negative x is equal to negative g of x. Okay, so this is the property of odd function, so therefore function g of x is an odd function. Okay, so this is how you prove the graph, whether they are odd or even, just doing in the algebraic way. Alright, so now as a summary, therefore we know, as a summary, based on the property of the even function and odd function, and then we could summarize that in for f of x equal to x to the power of n, if n is even number, which in other words even power, then the function f of x is even function. Okay, is even function. So this is important. Again, if we have another function f of x to the power of n, if n is odd number, so in other words it is odd power, okay, and then function f of x is odd function. All right, so this is important for you to if you can memorize it, that will be good. And then so therefore if you have a look about our example 35 on your booklet, and then so we just finished the example 35 A and B, and example 35 on the left hand side C and D, and then if you give it a go by using the method that I show you, so then they will have C is the even number as well, and D is the odd number over here. And then you see, let's have a look. So let me make it bigger. So if I look closely, then you see this power is even, and then so because we know if we have another function pure 6x to the power 4 and another function pure 3x to the power of 2, and these two functions minus together, so even function because of the power is odd number. Okay, so even function minus even function, and eventually they get an even function. And over here 6, 2, they are all even numbers, so even power, even function. So addition and subtraction doesn't change anything as long as each one of them is even function. So add them or subtract them and give you even function. So therefore you say if we have one even function plus or minus another even function, and then you will get even function still. Okay, and then any constant multiple. So if you have, for example, if you have f of x equal to x squared, so that is square, so it is a even function. And if we have 2 times f of x, which is equal to 2, let me change it to straight. So straight times f of x, so that means we'll have straight times x to the power of 2. Okay, so then straight times x to the power of 2 will still be an even function. So that's what they mean by any constant multiple of an even function, still an even function. And then here you see we have odd number, so that's odd function minus odd function plus odd function, and it'll give you odd function. And then that's 7, the power for 4x, the power for x is 1. Okay, so then you say that is odd function minus odd function, you still have odd function. So therefore that's why we say here odd function plus minus odd function, you still have odd function, and any constant multiple of an odd function you have, that will be odd. Okay, so let's come to example 36. So now I can put that away. Example 36. We are asked you to draw the graph x to the power of so f of x equal to x to the power 4. So then let me draw a Cartesian plan. And if I draw the Cartesian plan, okay, so for f of x equal to x to the power 4, and then we know when x is equal to 0, y will be y, which is also f of x, will be equal to 0. So we have original, and then f to the power 4, so we're going to be similar like compared to y equal to x squared, the parabola. Okay, so it's like a U shape. And then what we can do, so we roughly draw a graph, and then to make it accurate we can try a few number. Okay, so when x is equal to 1, y is equal to 1, let me do this scaling. 1 2 3 4. Okay, so that will be 4 8 12 16. Okay, so when x is equal to 2 and y will be equal to 2 to the power 4 will be 16 over here. So 1 2 negative 1 negative 2 when x is equal to negative 2, and x, so negative 2 to the power 4 is equal to 16 as well, so it will be over here. And so roughly we know the graph will be or we can just make it more accurate. When x is equal to 1 to the power 4 is still 1, so it's over here. And when x is equal to negative 1, x to negative 1, negative 1 to the power 4 still 1. Okay, so that will be over here. And then if I link them together, so your graph gonna be look like that. Okay, so look like that. So this is the graph for x to the power 4. And then we know, because that's the cube, the cube tells me the graph gonna be look like a S shape, okay? Not S shape passing through original. And so now so roughly let me use a different color. So roughly we know the shape for 2 times x cubed will be this shape, and that's my point of inflection. Okay, and then we're gonna pass that. Okay, so roughly gonna be look at that. All right, so now we need to find the intersection. Okay, so that's what we're trying to do. Solve the equation f of x equal to gx. So now because we know f of x is equal to x to the power 4 over here, so g of x is equal to 2x squared. So we need to find the intersection, the point of intersection. So we're gonna let f of x equal to gx, which is what doing question B. So f of x is equal to x to the power 4 equal to g of x, which is 2 times x cubed. And then we move 2x cubed to the left hand side, so you'll have equal to 0, and then common factor x cubed take it out, so you have x minus 2 equal to 0. Okay, so you see here log factor x cubed times this bracket equal to 0, so either x cubed equal to 0 or x minus 2 equal to 0. So therefore x is equal to 0 for this part, and this part is x equal to 2. So we have two intersection, and when x is equal to when x is equal to 0, so that's the point over here, point of inflection. And then when x is equal to 2, okay, so that is another point of intersection. So we know when x is equal to 2, the point and the x to the power 4 graph is over here, and then we know that is a point of intersection. So then I'm gonna draw the graph. So that's point of interest. Okay. So roughly we will have something like that. Okay, and then I can take this away, and the red part will be my 2 times x cubed. All right, so we finish solving equations. So x is equal to 0 and x is equal to 2. That is our point of intersection for the x value. And then C, solve f of x more than f of x more than equal to g of x. So then we're gonna do the same thing. So f of x is equal to x to the power 4 smaller than x to the power g of x, which is 2 times x cubed. All right, so we're gonna move this to the left hand side, so we'll have f to the power 4 minus 2x cubed smaller and equal to 0. Okay, so we're gonna do the same thing. And then to solving inequality, if you don't know how to do it, you probably need to go back to check your video of 6G solving cubic inequality. Okay, so if you don't know how to do it, look at the video over there. And so we take the common factor out just like we did before, and then make it equal to 0. So then we solve it out. So the x-intercept will be equal to 0 and x equal to 2. Okay, so that's my x-intercept. So now I can draw a graph for x cubed times x minus 2. Okay, so I can draw the graph for that. Then 0, 2, that's the 2 x-intercept, and then because it is a okay, so now we know because the a value it is 1 over here. So if it is 1, then we're starting from top right, draw this graph and then across. Okay, and then we are looking for smaller and equal to 0. So therefore we are looking for this part that is smaller than 0. Okay, so therefore x is larger than 0, smaller and equal to 2. So this is my solution. All right. So if you're not sure what I'm doing, or if you don't understand what I'm doing over here for this step, make sure you go back to check the video 6G. There's a detailed solution and explanation for you to understand how to solve the inequality for cubic inequality over here. Okay. Alternatively, you can also by observing the graph, because we already draw the graph over here. That is my f of x, and this is my g of x, because we are asking you to find f of x while it's solving f of x smaller than g of x. So have a look at this graph. The red one is g of x, the black one is f of x. So we are looking for f of x smaller and equal to g of x, which is this part. Okay, because only this part over here, that is the time f of x, the black one, is below this red g of x. So you see, and then the x value for that is between 0 and a. So this is another way to do it. Okay. For this question, example 36 can be a little bit confusing. If this video is not very helpful to get you understand, please make sure you ask me question in the class. Okay.